Okay, now what we're going to be looking at is the simulations we'd have given the observations that Galileo made. Now here we have Galileo's observations. Observations are critical here, and our simulations need to respond to that pretty well. Okay, so what we see here is Venus is showing, first of all, phases, just like the moon. Secondly, that the phases grow and decrease in size relative to how much light the thing is seeing. So when Venus is very big, right, then the crescent is sort of really small. And in this particular case, we almost have a new Venus. And then as the crescent gets larger and more gibbous, and then here's a quarter Venus, and then we have a full Venus down here, it gets smaller all the way down the line. And one of the things with the Ptolemaic simulation that we'll see in just a moment is you can't have these phases going on. Basically, it looks, you're basically running from essentially a full Venus to a full Venus. And so here we have, here's the Earth at the center. Here is Venus traveling around on this epicycle that's attached to the Sun, and here's the Sun. And here is our simulation that we would expect. This is what we would see of Venus as it's traveling around. And never do we see a full Venus as it travels around. We always see a crescent, so what I spoke about earlier is mistaken. But we never see a full Venus. And that's because the Venus is tied to the Sun. And it is tied to the Sun because it never gets far away. That's one of the key observations of the Ptolemaic model and these epicycles. But the fixation that the Sun is going around this Earth forces you to only have crescent Venuses, and never even as big as a half Venus. Okay, so now we'll go back and we'll take a look at how the heliocentric simulation is different in that regard. Okay, so here we go. And here we have the Sun in the center. Here's Venus, and here's the Earth. And the Earth is going to travel around its orbit, and the Venus will travel around its orbit. And here's the simulation of how big Venus gets, and here is the crescent nature of Venus, right? And we're looking, here's the portion that's lit up of Venus, that portion which is near the Sun, and here's the portion that's lit up of the Earth, and now we're looking at Venus. Okay, so if we look at Venus, we see from here to here. So right now it's a crescent. Okay, and this thing goes pretty quick, and we'll let it run for a little while, but here we go. When Venus is on the other side, it becomes a full Venus. Pretty amazing stuff. And then as it comes up closer and closer, it becomes more of a phase. There's a half Venus, and then now it gets big, and it's already passed before I can say anything. But as it gets big, it becomes more of a crescent. As it becomes full, it becomes smaller in size. Pretty amazing stuff. And that is the observation that Galileo made, and that is the observation that you can make as well. That's still pretty amazing stuff. So, if you will, another picture of this sort of thing, you see crescents of Venus when it's close to us, and you see a full Venus when it's far away on the other side of the Sun relative to us. So, Copernicus was right, although he was wrong as far as everything going around in circles. Well, anyway, we think pretty much of these guys. Now, we could say geocentrism is dead, although one of the things that can occur is there are a couple of things on the internet you can find, the official geocentricity website, and then you could also, I like this one better. I like the titling of this thing. If you see, Galileo was wrong, the church was right. So that will end our discussion here about history. And I want to say one more. I'll have another video set up for looking at what the Greeks did as far as figuring out the distances to the Sun, to the Moon, and the sizes of the Earth, the Sun, and the Moon. I think it's just amazing what they did, and I want to reproduce that for you. Okay, we left off here, and I wanted to include one more chart. This will help in your discussion ideas. And as I showed you the two websites that I have here for Geocentrism is Dead, well, kind of, not really. No idea goes unpunished, if you will. But this would be an in-class exercise I would ask my students in the face-to-face class. Basically, I would ask them to overthrow the Ptolemaic worldview and use your observations to support your statements. So to remind you, we have these three views that Ptolemy used to show that the Earth is at the center of the solar system. And the three views are, or the three points are, there's no apparent motion on the Earth, the heavens are perfect and unchanging, and stars appear the same independent of season. They don't change relative to each other. So I want you to think about that. If you don't have answers right away, that's fine. But the idea is that you could use this to facilitate your understanding of the chapter as well as discussion topics. All right. Thank you, guys. Thank you very much.